Hi, I am Aditya Singal and I'll be presenting my project for the ELP101 course on electric doorbell and yet the use of transformers in it. The electric doorbell is a simple circuit that triggers a sound on the completion of the circuit by pressing the button. It is the simplicity that makes the doorbell such a marvel. The simple devices in the doorbell put the scientific principles of electromagnetism into action in a useful way. The components of a doorbell are transformer, gong, motor, hammer, and soft iron strip. This is a diagram showing the internals of an electric doorbell. Hammer is attached to the soft iron strip which hits the gong when the button is pressed and the circuit is completed, making the classic bell chime. The magnetic motor constitutes a conventional electromagnet. An electromagnet is a coil of wire often wrapped around a piece of magnetic metal. Electromagnets work on a very simple principle. Running electrical current through the wire creates a very small magnetic field around the wire. Coiling the wire amplifies the magnetic field, so it has a substantial effect on any magnetic objects around it. Just like the magnetic field around a permanent magnet, the magnetic field of an electromagnet has a polar orientation, a north end and a south end, and it is attracted to iron objects. When you hold down a doorbell button, it closes an electrical circuit so that household current flows through the electromagnet by way of a transformer. Transformers. A transformer is defined as a passive electrical device that transfers electrical energy from one circuit to another through the process of electromagnetic induction. It is most commonly used to increase or decrease voltage levels between circuits. The electric doorbell utilizes the step-down transformer as it requires low energy to operate. Working principle of transformers. Mutual induction between two or more windings, also known as coils, allows for electrical energy to be transferred between circuits. If one coil is supplied with an alternating electrical source, the alternating current through the winding produces a continuously changing and alternating flux that surrounds the winding. If another coil is brought close to this winding, some portion of this alternating flux will link with the second winding. According to Faraday's law of electromagnetic induction, there will be an EMF induced in the second coil. If there are more turns on the primary coil than the secondary coil, then the voltage will increase. If there are fewer turns on the primary coil than the secondary coil, then the voltage will increase. The ratio of the output EMF to the input EMF is equal to the ratio of the number of turns in the secondary winding to the number of turns in the primary winding. Faraday's law states that an EMF will be induced in a conductor which is exposed to a changing magnetic field. This is the working diagram of a transformer. Here we can see that on the left there is the primary circuit and the right there is the secondary circuit. And we can also see that Vs by Vp is equal to Ns by Np, which means that the ratio of the output voltage to input voltage is equal to the ratio of the number of turns in secondary to the number of turns in primary. Working principle of an electric doorbell. When you press the doorbell button, you complete an electrical circuit that allows household electricity to flow through the doorbell's internal electromagnet. The magnetic field generated by the electromagnet is then used to power a mechanism that creates the doorbell sound. Doorbells are low voltage devices. This means that they require relatively little energy to operate. An important part of a doorbell mechanism is the transformer. The transformer converts a regular 120 volt household current to the lower voltage, usually somewhere between 6 to 16 volts, required by the doorbell. In a doorbell, the electromagnet operates a self-interrupting circuit. When the button is pressed, the circuit closes and the electromagnet moves a contact arm. When the contact arm moves, it interrupts the circuit and the electromagnet stops. When it stops, the contact arms fall back into position, completing the circuit and starting the process all over again.